we've got a question. We have a straight line, x plus y equals k. We have a circle. We've got an equation. We're told the line is a tangent to the circle, and we have to find all of the possible values of k. Actually, not just find k, find all the possible values of k. Okay. So if it says all the possible values, it is suggesting there is more than one. What's the easiest bit of this? The line or the circle?
Circle.
Oh, that's not the answer I was expecting you to say, probably.
Line.
Straight lines are generally easier. So let's look at this x plus y equals k. I was hoping that from GCSE you could tell me what that looks like.
And it looks like the
Right, I'm looking at you sort of backwards, but you could be right in what you're doing. Can anybody tell me a bit more specific? Yeah?
It is negative.
Negative gradient, yeah. Going through what points?
K
Where?
on the y-axis.
K on the y-axis. So it's downhill, so it could be like that or like that. I need something else as well, another point.
point on the
K on the x-axis, yeah, that's right. If you have a line, x plus y equals number, find that number on the x-axis, find that number on the y-axis, and I'm just going to turn that around a minute, because I can't do a straight line at that angle. That is the line you get. So GCSE, you should have been familiar with lines like y plus x equals 5. You'd find 5 and 5 and you'd join them up. So this line is a downhill line. What is the gradient of that line?
the X. No.
-1. Yeah, okay. It's gone the same amount across as it has down. So I do also know the gradient of that line is -1. But I don't know where k is. I mean, it could be there. I mean, it could be that k is down here somewhere. It could be, down here. But it's got that gradient, and wherever k is, it goes through those values. So I don't know what k is, but it's going to look like that. Now I've got a circle. Let's look at the circle then and start off doing what we've done every question so far, pretty much. So I'm going to write its equation down. What am I going to do next, anybody?
Rearrange it.
Rearrange it, yeah. My x squared bit and my x bit and the gap. My y squared bit, my y bit and a gap, and shift the number. Right, James, choose somebody.
Me.
Yeah.
Jack.
Jack, first bracket.
X plus 2.
And what do I need to take away from that? Yeah, okay. So that plus 2, remember, was half of that, and 2 squared is 4, has to be taken away. Jack, choose somebody, please. Gracie, second bracket.
Y minus 3.
And, yeah, what have I got to take away from that one?
9.
Okay. And I need to put my plus sign there. So I've got x plus 2 all squared plus y minus 3 all squared equals minus 11 plus 4 plus 9. That's giving me 2, isn't it, on the right?
Yeah.
So I know the centre is something, and I know the radius is something. Gracie, choose somebody or go for it yourself. Centre? Emily, centre?
Minus 2, 3.
And I'm alright thinking that's the first one we've had with a negative coordinate there.
I think so.
Yeah, I don't think we've had one like that before. And the radius, Emily?
Just root 2.
Yeah, root 2, that's right, okay. And if we're going to do a drawing in a minute, it would be useful to know roughly what that is as a decimal. What's root 2?
1.3.
1.4 something, okay? So if we're doing a sketch in a minute, if we know it's 1 point something, that's the main thing. So, okay, let's do a sketch then. Oh, I normally start with my circle, don't I? But I haven't this time. Right, I've got to think hard now then. So the centre is at minus 2, 3. And that's going to be 2, that's going to go off the page there, isn't it? Minus 2, 3. Its radius is 1 point something. So is it going to touch any of the axes?
No.
No, because it's got 2 to go that way, 3 to go that way, and it's only going to go 1 point something. So my circle is not going to touch an axis, so it can go there like that. Okay. Now, I've got 2 of these tangent lines. Well, I've got these tangent lines, and it's only got to touch the circle once, and it's got a -1 gradient. So if you imagine my pen, is a -1 gradient line, and it's just touching a circle once. That could happen there. Then all of these points now, it's crossing it twice, and it could happen also here. So my two lines, I'm just going to rotate the paper so I can draw this. It's going to be sort of there and there. Those are my two tangents possibilities. Let's call that tangent 1 and call this one here tangent 2. Those are the two possible tangents. So I'm either going to have k value here and here, or I'm going to, if I extend that, a k value here and here. So I've got to find those, well, I've got to work out these things here. I've got a line touching a circle. Had a line touching something last time. What did we do if something touched something? It's a point of intersection. What did we do last time? Yeah, okay. If we call these two things here A and B, so A and B are our tangent points, they are points of intersection. They're points of intersection between our line and our circle. I think I've written those equations down correctly. Now, again, it's simultaneous equations. That's what we've got. And again, there are various different methods of solving them. Anybody got a suggestion? These aren't two linear ones, though, so maybe there aren't so many actually ways of solving this one. What do you think would be a good way to do this one?
Make them equal. No, don't.
Substitute, okay? So we're going to do it by substitution. We either need to know what x is equal to, or we need to know what y is equal to, okay? From here, I can easily rearrange to work out what y is equal to. What will y be equal to for that one? K minus x, okay? And I can substitute that into my circle one there. So I will rewrite my circle equation, but every time I see a y, I will write k minus x instead. So I'm going to get x squared plus y squared. We're happy with what's on the board there. Next thing to do, multiply out, get all the bits together. What's k minus x all squared? You can either do it as a multiplication grid if you need to. Some people may just be able to tell me. Go on.
K squared plus x squared. And then minus 2kx.
Yeah, that's right. Okay, that's just a normal way of writing it. There's nothing wrong with the order you said it in. But that's just a normal sort of way of writing it. That's being added on, so I haven't got to worry about any minus signs being sort of brought in from anywhere else. Plus 4x minus 6k minus 6x.
Yeah, plus 6x.
Yeah, plus 6x. 2 minuses, I make that plus 6x. Plus 11 equals 0. Okay. What am I got here then?
You just group things.
Yeah, I can group them. And what will I get?
No, that's quadratic.
Yeah, I get here a quadratic in x. So we will group them. I will group the bits together. X squareds there and there. There are no other x squareds, so I've got 2x squareds. X bits there. That colour doesn't work. Just trying to. There's an x bit. There's an x bit. There's an x bit. Right, these two x bits make 10x, and I'm taking off 2k. So I've got 10 minus 2k, lots of x, which has to be added on. And then I'm left with bits without any x's in at all. I've got an colour didn't work. I ought to remember that. I've got an 11 over there, a minus 6k there, and a plus k squared there. So I've got a k squared, a minus 6k, and an 11 has to be added on. If you want to put that in brackets, you can do it. It doesn't matter if you just want to show that's a bit without any x's or x squareds in. Now, what do I know about the point of intersection? How many times does each tangent cross the circle? Once. So I'm looking, because it's a tangent, I'm looking for one point of intersection. So that means from this equation I am looking for one root. This equation has one root. One root, quadratic equation. What bells should that be ringing in your heads? Discriminant, I heard somebody say, and over here as well, yeah. So we should be thinking discriminant equals 0. If we've got one root from a quadratic equation, discriminant equals 0. What's the discriminant?
B squared minus 4ac.
B squared minus 4ac equals 0. Because this thing is quite complicated, I'm actually going to write down what A, B and C are. A is how many x squareds I've got? 2. B, how many x's I've got? It's this green bit here. 10 minus 2x. C is the bit that's stuck on the end.
2k.
Sorry, thank you very much, 2k, thank you. C, the bit that's stuck on the end, is all of that bit over there. So, my b squared minus 4ac, well, you can probably do this as well as I am. I'm going to write it down. I'm going to stop talking for a minute, but just have a go at doing this bit. So, if you're not sure, that bit there was that bit there when you multiplied it out. If you want to use a grid method, that's fine. Lucy, I wouldn't bother trying to follow this example for the time being.
I think it's 20k.
Here,
No, it's
you will get minus 20k from when you do the outsides, and you'll get it again when you do the middles. You'll get
Okay.
2 minus 20s, which will combine to get the minus 40.
Right, fair enough.
Okay. Right. Now, what we've got here, what's this given us?
Quadratic in terms of k.
Quadratic in k. Yeah. So, let's group this together. Let's look at the k squared bits. I've got 4k squared and a negative 8k squared. Now remember, it is k I'm trying to find, so just having k's written down is actually quite a good thing. K bits, I've got a minus 40 plus 48, that's plus 8. And the number bits, I've got 100, take away 88, which is positive 12. And I'm still sticking to my promise that this is shorter than the last example.
Took about 2 pages.
Right. Now what? What would you do if you saw that?
Factorize.
Divide by 4. Okay. Divide by 4. You could divide by minus 4.
get rid of the minus.
If you divide it by minus 4, I think it makes it nicer. So yeah, what we are doing here then is dividing every bit by minus 4, and that gives us k squared minus 2k minus 3 equals 0, which looks far less horrible.
It can be factorized.
And according to Callum, that can be factorised into what, Callum?
K minus 3, k plus 1.
Does that work? That works. So, drum roll, and what do we get?
K equals 3, K equals minus 1.
k equals 3 or k equals minus 1. We were asked to find the possible values for k.
And we have
We have found the possible values for k. If I go back about 2 pages and find my diagram, I have a diagram here. I was expecting, from my sketch, one of these k's to be positive, one of these k's to be negative. That's what I've got. So I know that was 3, that was 3, that was minus 1, that was minus 1. Those were the possible values of k.
Right.
I think you can see that this question in this chapter has brought in quite a lot of stuff from previous chapters as well. Some of these chapters are called synoptic chapters, bringing lots of bits together.